I'm here to present you this time the developments I did to try to turn the Eclipse idea into an Arduino programming platform, but for kids. So, children are such curious creatures. They explore, they question and wonder, and by doing so they learn. From the moment of birth, like even before, humans are meant to learn new things. So when we are curious about something new, we want to explore it. So a good way to discover is to explore by yourself, trying, encountering success and failures. And this way, kids learn causes and effects. Today, the world is made of computers. At home, in TVs, DVD players, coffee machines, electronic toys, pet robots. Outside, in cars, planes, phones. So nowadays, kids are used to play with tablets and computers, and they are curious to understand how video game is created, how computer works, and what is electronic. So one of the things kids have to learn is electronics. But the idea to learn electronics for them is mostly to understand that they can use sensors to listen to the environment, and that it exists actuators with which they can interact. We expect that they understand that these modules are connected to platform which contains software. So nowadays it is really easy to get good material to learn electronics thanks to the Open Hardware initiative. The problem with electronic is that it is most of the time small things. So it is not so easy for kids to manipulate. And it is so easy to do a bad connection and just damage your electronic module. But an open hardware company proposed a really cool electronic modules to solve this issue. Little Bits is an open source library of electronic modules that just snap together with tiny magnets. There is no soldering, no wiring, no programming. So it's great to understand electronics, but not to understand programming. And so it's not really great to perceive and comprehend the connection between software and hardware modules. The most famous open hardware platform is Arduino. With Arduino, you get a piece of hardware, but also documentation and development environment that fits all together with the hardware. The Arduino board is like a small computer that can be programmed as many times as needed. As a computer, it provides I/O interaction, so digital and analog pins. And the Arduino can sense the environment by receiving input from a variety of sensors, and it can affect also its surroundings by controlling lights, motors, or other kind of actuators. So the microcontroller on the board is an Atmel IVR microcontroller, and usually is programmed using the Arduino programming language and the Arduino development environment. So what's great with Arduino is that it is cheap and really easy to find. There are many efficient providers available on the internet, like Adafruit, DFRobot, Studio. They provide an incredible amount of modules and order, and 2 days later you will have received Atom, your new toy. So, then to understand the world, the kids have to learn also programming. Many different initiatives are arising to learn programming to kids. These movements use many different kinds of software, open source software or proprietary software. The most famous, Turtle Logo, is for the eldest ones, but more recently, Scratch has become more popular, and these tools have different approaches. In Turtle Logo, kids write text to move a small turtle cursor in order to draw shapes. There is no graphical UI, it's a very simple language. They learn the concepts of programming and understand that a program is just a suite of instructions. In Scratch, you drag and drop elements from a palette to animate a character. This tool is a complete IDE, which allows kids to create cartoons, video games, or movies. This tool provides a more graphical UI, and the kids have to assemble puzzle pieces, which are instructions to describe a program. So these tools are great to learn what programming is, but it exists also other kind of tools that allow kids to program the real world by interacting with sensors and actuators. So open source tools like Scratch for Arduino, ArduBlock, provide UIs for simple programming of the Arduino platform. And thanks to these tools, kids can develop a software, upload, and run it on hardware platforms. So Eclipse is one of the most famous IDE. It has millions of users all over the world. So what we could imagine is that kids could use it also to learn programming. But if we give them the original Eclipse IDE, it seems that the Eclipse UI and the default available languages like Java or C are too complex for kids to discover programming. So the idea was to develop a prototype to allow kids to create small programs. So our first actions were to simplify the UI, the project lifecycle, and to provide a graphical block language to be able to develop simple programs and run them on electronic modules. The purpose is not to provide a complete IDE, but a tool giving the possibility to discover the effects a software program could have on electronic modules. So the UI of the Arduino designer defines no menu, just one toolbar with 4 different buttons to manage the project, define the hardware modules used, and to define the software that will be uploaded on the hardware platform. A dashboard helps the kid by indicating what is the next step in the process development. And the process is really simple, in fact. The kid must describe the connection between the hardware modules, then he describes the software, and finally, he uploads it to the target. So first step, the kid defines the hardware platform he is using, and the different sensors and actuators he connects to the Arduino. Then, you have to know that software written using Arduino is called sketches. So then the kit describes the sketch, which represents the software that would run on the hardware platform. And finally, he uploads the sketch to the target. For the prototype I will demonstrate, I am going to use a DF robot hard develop kit, which contains ambient light sensor, infrared sensor, sound sensor, push buttons, rotation sensor, and other. It has also some servo motors, and I also bought a fan and a music player shield. So for the first demo, I will create a small hello world sketch, and as we are in the real world, the hello world would be to blink an LED. Okay, it's not on the good desk. So this is the Arduino designer. I need to see. And so the idea is to create a new project. So we create one, and automatically it will open the dashboard. And in the dashboard, you just have to do what he says. So double click to describe the hardware. You have to select a platform. It's not on the good. Okay, so I select the DF Arduino for me. And then I have to select the module. Okay, it's not on the... I'm sorry. I can't go to this desk. Okay. And this one, and then I select the blue LED. And I just connect the blue LED to the pin 13 of my Arduino. When this is done, I go back to the dashboard. I have a new step. Double click. Now I have to create a sketch. So what means to get a blinking LED, what you have to do is first to get the blue module, the blue LED module, switch it on. Then you have to wait some time, for example, 100 microseconds, and then get again the blue LED, but switch it to off. Add another delay. And just close my sketch as the sketch in Arduino is a loop. When this is done, I could upload my sketch on the Arduino platform, but as it is the first time I use this environment, I have to set in the preference where is my Arduino compiler. And now, just by clicking here, it generates the code, compile it, and upload it on the platform. Or not. Okay. There is a problem. I need to save, maybe. Okay, compile, upload, and okay, that's great. We have a blinking LED. And that's very cool for me, as I'm used to play with modeler. Here I'm able with Eclipse to get a blinking LED. I think you can upload. I think it's great. Okay. So as you can see in the Arduino Designer palette, I defined a simple graphical block-based language. With this language, it's possible to create instructions like while, repeat, and if instructions. Then it is possible to use functions like the delay, and it's also possible to reference hardware modules. It's also possible to create variables, constants, and some mathematical operators. But for this prototype, I decided to create a low-level language which is still close to the Arduino language, but we could imagine to provide higher-level functions. So, to develop the graphical designer, I used Sirius. As I present you Sirius this morning, I will not repeat what it is. So why I am using Sirius? Just during the prototype development phase, it allows me to develop really quickly an Arduino-specific modeler. And I choose it also because I'm used to work with Sirius in my daily work. And I just want to develop with Sirius something which is cool. That's all. For the kids, they get a tooling completely adapted to the development of small Arduino projects and simple to use. So the first step, as I showed you this morning, in the development was to define a new DSL specific to Arduino, which allows me to describe what is an Arduino hardware and what would be sketches. Then, second step, I defined the different kinds of representations I wanted. And I mapped different concepts defined in the Arduino meta model to graphical elements and defined the different tools provided by the designer palette. Next step was to develop a small generator with Axeleo to generate from Arduino's model the sketch. In Arduino, sketches are saved with the file extension .ino, and the Arduino language is based on C and C++. It uses the AVL libc package, which provides a subset of standard C library, but for Admiral IVR microcontrollers like the Arduino. And if we have a look to the generated code, we can see that Arduino programs can be divided in three main parts. There is some structural element like setup, loop, if, repeat, while. There is values, you have variables and constants. And there is function like pin mode, digital write, analog read. The setup function is called when a sketch starts. It is used to initialize variables, pin modes, start some libraries, and many other things. The setup function will only run once after each power-up or reset of your Arduino board. And after generating the setup function, my generator creates a loop function, and this loops consecutively, allowing the program to change and respond. So when you use the Arduino environment, the compile and upload actions are directly integrated. But here, as I want to integrate the generation and the compilation of INO files in my Eclipse application, I searched how to compile and upload Arduino programs, but from the command line. So I use AVR GTC and AVR Dude to do this. And I just integrate all this in Java program and integrating this inside the Eclipse IDE, inside the upload button. So for the next demo, I will use the LED and connect it to a push button in order to switch on off the LED according to the button is pressed or not. So I will just open existing project now. So my project would be the simple input. If we have looked to the hardware, we will see that we have a push button connected to the pin 0 of my Arduino. There is a blue LED connected to the pin 13. If we have a look to the sketch, it's really simple. What it means is when the push button is pressed, the blue LED will switch on. Okay, I just generate, compile, and upload the code. And now, when I push the yellow button, the blue LED is switched on. So it works. The next example demonstrates how to change the brightness of a LED in order to get a fading light. Okay. So, still opening an existing project. Fade light. For the hardware, we will have just one white LED connected to pin 11. For the sketch, a little bit more complicated. What it means, he said that while the variable brightness is under 255, we will just increment it and set the value to the white LED. Wait for some time until we will until we will have the brightness variable is equal to 255, and then we will just decrement it and decrement the value of the brightness variables and still affect it to the white LED. So, compile, upload, and now, if we have a look at the white LED, which is here, you can see that the brightness is changing according to the time. It's another thing. It's not a blinking LED, but you can upload. Yeah, you understand. Okay. I will just switch this one on. So as you can see, the Arduino designer allows to develop really simple projects. But thanks to different functions I already demonstrated, I am able to build more complex projects. So why not to build a robot? So I want to present you my new electronic art car, which is named Tiger. So, Tiger is made of many sensors and actuators. So you will have a beautiful button, and some beautiful LEDs. White one, blue one, and the red one should be somewhere. Okay. He has also a sound sensor and a big eye. To build him, I decided to use high-tech composite materials coming from my trash can. So he's made of carton and lots of scotch tape. Lots of scotch tape. So what this electronic cat is able to do? First, it can feel. When you push his button nose, that will command its blinking necklace. So we have to upload the code. Tiger necklace. So for the hardware, a push button and 3 LEDs. The software, when the push button is pressed, we will repeat 5 times the sequence: blue LED on, white LED off, white LED on, red LED on, and then all switched off. So if I upload the code, now, normally, when I push his nose, his necklace is blinking. But we could do better. He can see, and that will command its servomotor tail. servo motor, a music player, but I'm not sure if it works. It will work. An infrared sensor that will be is high. And for the sketch, if the infrared sensor detects something, normally the music player should be switched on. The servo motor would go to the position 0, then wait some time, go to position 90, and repeat this until the infrared sensor detects something. So if I upload the code now, normally, when the cat sees something like a fish, he's moving his tail, and if I put the sound, okay, he lost his tail again. All the time. Okay, that's a problem. Okay, we could do it again, just for fun. And his mouth is melting also. That's really fun. But in fact, we could do better, normally. Because it's able also to hear a sound, and that will command its bubble machine. The bubble machine is composed by a servo motor that commands the bubble stick, and a fan, which is here. And as the fan needs 12 volts, and the Arduino could provide only 5 volts, we have also to add a small battery and a small circuit to energize the fan. Okay, so if we have a look to the code now, for the hardware, there is a fan connected to pin 7, there is a servo motor, there is a blue LED, just to see if the cat hears something or not, and a sound sensor. And for the sketch, we have this. If the sound sensor detects a certain level of sound, then we will switch on the blue LED in order to know that he hears something. And then we will repeat this 3 times. The micro servo of the bubble stick will move to position 0, then the fan will switch on, then switch off, and the micro servo will go to the position 60. So if we upload the code, and if we make some noise, it's not really working. Okay, make some bubbles. Make some bubbles. Okay, so that's really funny. So you have to know that we made this with Sirius. So you can see more serious presentation about Sirius on the website and on the eclipse.org Sirius website. So just switch it off. Okay, you can find the code also of what I present to you on my GitHub account on the Arduino repository. And you should find soon some projects for Windows and Linux on my GitHub account also. And there is already some documentation available on the GitHub wiki. And you will find there all the examples and tutorials and explanation about how to contribute to this project also on GitHub. So thank you, and just make noise.